We're looking at determining the direction of force that a charge, moving charge, experience in presence of a magnetic field. For this, of course, we need to know the direction of the field itself. Say this is the direction of the field. We need to know in what direction the velocity or the charge is moving basically. So velocity, it can be along the xy plane at a random angle, or it can be zy plane again at a random angle. So that's your P and that's your V. We know for sure that the force will be in a plane or perpendicular to this plane. This is the plane that contains plane with V and B, right? The force will be perpendicular to this plane. So basically, force will be along x-axis. That is for sure. Okay, but is it the positive x-axis or the negative x-axis? That's the question, right? To help us with that, we have two rules. You can either use Fleming's left-hand rule or your right-hand palm rule. I do want to add the word palm over here. It helps. So how does this work? First thing first, we need to stretch your left hand such that the thumb, forefinger and the middle finger are perpendicular to each other. So let me draw that. So make it easy. That's that, this. Okay, simple diagram. Keep it simple. Now, stretch your, we did that, thumb. This is your forefinger, that's your middle finger. Align your forefinger in the direction of magnetic field. So that's your forefinger. It's in the direction of magnetic field. Align your middle finger in the direction of the current. So our current is actually upwards. So you can imagine us turning. So this is the direction of current. Okay, so basically V, not I. That is wrong actually, what I wrote. Your thumb will point in the direction of the force acting on the conductor. Sorry, not conductor, in this case, charge. So basically, it is going in the negative x direction. So it would be in this direction. So that will be the direction of velocity. Think about it. So if I point this, in the y direction and V up in the z direction, the thumb should be pointing in the x direction. If you're not getting it right, means you're doing it with your right hand. That is a possibility. You are so lost that you're thinking something else, and so recalibrate yourself. Take a second. Right, now make use of your left hand. Okay, is it coming? Right, it comes. So now, how do you remember this? I remember it this way. If you guys have your own way, that's okay. I mean, please do that. That's good actually. So father, mother and child. So child stands for current, mother stands for magnetic field, and father stands for your force. That's one of the ways of remembering it. If you have your own way, that's also helpful. Next, let's look at palm rule. So the diagram of this will be quite simple actually. Here we are using right hand. Remember that. Extend your right hand with your fingers straight and your thumb pointing perpendicular to your fingers. So basically this. Very simple diagram. It looks like I think this is okay. So this, align your fingers, point your fingers in the direction of the magnetic field. So my hand will go that way. Point your fingers in the direction of the magnetic field. Point your thumb. Okay, point your thumb. Point your thumb in the direction of the velocity of the positive charge. In our case, it's going up, so that's good. So that's your velocity, that's your magnetic field. So my palm is other way in the other side. So this I'm looking at my knuckle. So let me represent that way. So that's my palm. This is my knuckle. And palm direction, it's pointing in this way for me. Do that, don't be lazy. That will represent the direction of the force. And this too is giving us the same thing. So this is much convenient, right? So if I point my, let me use some other color. So my right hand, if I do this with knuckle showing towards us, that's your B. That's the V that matters. And your palm will be that way, and that is a direction of force. Okay, does that make sense?